Welcome to my YouTube channel. I'm Khazar Chugtai, and today I'm going to explain basic organic reactions, reagents, conditions for O-level organic chemistry. Let's talk about it. Here are basically four reactions. Some reactions because of alkenes, the chemical properties of the alkenes, chemical properties of the alkenes, chemical properties of alcohol and carboxylic acids, and some reaction because of polymerization. Let's talk about the chemical reaction of alkanes, then alkene, and so on. Alkenes give two chemical reactions. Number one, that is said to be a substitution reaction. The first one is said to be the substitution reaction, and other one is combustion reaction. In case of combustion, there is a reagent that is said to be oxygen. In the plentiful supply of oxygen, different alkanes are heated, and the heat is, in this case, that is said to be the condition. Condition is heat. Reagent, you can say, is oxygen. So in the presence of plentiful supply of oxygen, heating an alkene gives CO2 and H2O. That is said to be the product of complete combustion. But in case of incomplete combustion, you may have, in case of incomplete combustion, there may be the formation of carbon black solid, that is said to be the soot. There may be formation of carbon monoxide. There may be the formation of carbon dioxide, CO2, and water. So in case of incomplete combustion, you may have 1, 2, 3, and 4 products. But in case of complete combustion, if we are going to combust a simple hydrocarbon, a compound that is having carbon and hydrogens only, then there will be the formation of CO2 and H2O. Now come towards the substitution reaction. In substitution reaction, alkanes are allowed to react with the halogens like fluorine, chlorine, bromine in the presence of UV light. So condition is UV light, and the reactant or the reagent is Cl2, you can say. In this case, there is a substitution of hydrogen by halo group, by Cl, by Br, by F, and so on. So each time one hydrogen is replaced and one halogen is introduced. As a result of, there is a formation of an inorganic product that is said to be HCl. So this substitution is basically in a stepwise mode. Each hydrogen is replaced turn by turn, and finally we will get all substituted halogen, or all hydrogen are substituted. So in first case, you can see that it's said to be chloromethane. 1 chlorine is substituted. In this case, this is a dichloromethane. 3 chlorines are substituted, trichloromethane, and finally it is tetrachloromethane. And every time there is the formation of HCl, HCl, and HCl. The next one reaction that can be visualized in this aspect with respect to the alkenes, you can say that cracking, that is said to be the cracking. Cracking is a chemical reaction in which a large hydrocarbons, a large molecule is heated under the presence of the catalyst, in the presence of the catalyst, and there is the formation of small molecule. So the cracking is the process in which large molecules are broken down into the small molecule, and one of the type of the small molecule, you can say, is alkene. One of the small molecule is alkene. Other molecules may be alkene. If this molecule is supposed to break into 2 parts only, then it is true that one part will be alkene and other part will be an alkane. The next part is the chemical reaction because of alkenes. Alkenes exclusively mainly gives addition reactions. There are basically 5 reactions. Those can be seen from alkene. One is the typical one, the previous as that of alkene. It can be combust in the presence of excess oxygen, and it can be heated, and it will combust. It will change into CO2 and H2O. Once again, if oxygen is not in the sufficient quantity, that is not in excess, so there may be once again the formation of carbon, that is said to be the soot, carbon monoxide, carbon dioxide, and water. 4 products may form. The rest of all reactions are said to be, 4 reactions are said to be addition reaction. Number one, you can add Br2. Aqueous bromine can be added in the presence of in the presence of organic solvent. This is the typical reaction that is said to be the test for unsaturation. So if you are going to add Br2 in dark, on addition of bromine, color of the bromine is destroyed. So this compound, that is newly bond compound, that is 1,2-dibromopropane in this case, it is a colorless compound. So the color of bromine is destroyed. The next reaction is you can add H2O, that is said to be steam, heat at 70 atmospheric pressure. Steam plus heat plus atmospheric pressure. You can add H2O. This is H2O. HOH means H2O. One bond of the double bond is broken down and you will get OH group on one carbon, H group on the other carbon. If this alkene is unsymmetrical alkene, you will get two type of alcohols. I mean, two products will be formed. If it is unsymmetrical alkene, this steam, this water is also unsymmetrical. So there will be the formation of two different products. In one product, the OH will be at carbon number 1, that is this one, and it is said to be propane 1-ol. In second one, OH group will be on the second carbon, and this will be the new compound, the different compound. It is said to be propane 2-ol. The next one is the alkenes can be added up mutually, and they can form a polymer that is said to be an addition polymer. So alkenes have exclusively typical chemical properties that they can be added up with the same or with the different alkenes, and they can make a polymer that is said to be addition polymer. The fifth one, you can add HCl, you can add HBr, and so on. Once again, one of the double bond is broken down and there is an introduction of Cl on the one atom, H on the other atom. Similarly, there is again the possibility of formation of two different compounds. One compound is over here that is said to be 1-chloropropane, and other compound will be 2-chloropropane, like that. It will be 2-chloropropane and so on. So once again, two products will be formed. Now come to the next one, reactions because of the alcohols and carboxylic acid. Alcohol can be further changed into a carboxylic acid. Alcohols can change in ester compounds. Alcohol once again can reversibly change back into the alkenes. Alcohol can change into alkene. Once again, the conditions are basically in this case concentrated sulfuric acid and heating at least at 170 degrees Celsius. The second one is acidified KMnO4 heat under reflux. That is the typical conditions. This KMnO4 is the reagent in conditions is acidified and heat under reflux. So alcohols, if the primary alcohol is over here, it will convert into the carboxylic acid. Simply speaking, as far as your level is concerned, alcohols can be convert into the carboxylic acid by applying these conditions, heat under reflux and acidified solution of KMnO4, and this KMnO4 is an oxidizing agent. This reaction is said to be oxidation reaction. The next one is when alcohol is allowed to react with a carboxylic acid. Alcohol plus a carboxylic acid under the condition of acid and heat, it will meet together. They will meet together to make a compound that is said to be an ester. This whole compound is said to be an ester, and its observation is a sweet smelling liquid. Next one, reactions are because of carboxylic acid. Basically, 4 reactions are there because of carboxylic acid. 3 reactions were because of alcohol. 4 reactions are because of carboxylic acid. Carboxylic acid gives the typical reaction with alkali like other mineral acids. It can make salt and water when it is allowed to react with a base or an alkali. Same is the case when it is allowed to react with the sodium carbonate. There is formation of CO2. That's a typical reaction one. That this reaction can be used as a test of carboxylic acid. There is the formation of CO2, H2O, and salt is formed. The next one is, once again, a carboxylic acid can react with alcohol, any sort of alcohol, for example, ethanol, under the condition of acid and heat. And once again, there is formation of an ester. That is said to be an ester. And the last one is if NH2 compound, any organic compound that is having an H2 with the carbon atom, they react with the carboxylic acid. When they are heated together with the carboxylic acid, ultimately they yields an amide. Amide formation takes place. The last one is the formation of, you can say the polymerization, formation of condensation polymers. Condensation polymers are formed when a dicarboxylic acid, this is the dioic acid, normally speaking, are allowed to react with the diol. A compound having two OH group is generally said to be diol. This is a general dioic acid, it's a general diol, and under the conditions of acid and heat, they react together and there is a condensation. OH group from carboxylic acid side and H from alcoholic side, they meet together and there is elimination of water molecule. Finally, there is the formation of this linkage that is said to be ester linkage. That is said to be an ester linkage. So in this case, when dioic acid and diol are allowed to react together under certain condition, it is said to be condensation polymerization. This polymerization can be reversed. This can be reversed by adding dilute acid and heat. Once again, there is the breakage of ester linkage or ester bond, and once again it will convert into back its original reactant. Those are alcohols, diol and carboxylic acid. The next one polymer is condensation polymer. In this case, once again a diol, generally speaking a diol and diamine this time. Diamine, NH group, one NH group over here. Here is another NH group. So diamine, one diamine and one dioic acid are allowed to react together. They are heated under certain conditions and there is the formation of this amide linkage. An amide linkage is formed and so on. Once again, this compound, this polyamide, this once again can be reversed by heating with the dilute acid or by heating with aqueous NaOH, and they will change back into the original reactant, dioic acid and diamine. The last one, the polymer is said to be protein, or sometimes it is said to be polypeptide. In this case, each molecule is an amino acid. When two same or the different amino acids are allowed to react. When two same or different amino acids are allowed to react together, they are going to make the similar linkage as that of amide, but this time this linkage is said to be a peptide linkage. It is said to be a peptide linkage, and the whole molecule, its repeating unit is over here, and this whole molecule is said to be the protein, not the polyamide. And once again, there is the formation of H2O molecule. This is again an example of condensation polymerization. Same or different amino acid meet together to make a polymer that is said to be protein. Same was the case over here. It is again an example of condensation polymerization when dioic acid and diamines are allowed to react under certain condition. Then there is the formation of a condensation polymer, but this time its name is polyamide. The previous one, the first one, that is dioic acid, when is allowed to react with a diol, then there is the formation of a condensation polymer that is said to be a polyester. The next thing that you must know is the branch structure and unbranched structure. If you're having a compound that is having more than 3 carbon, let's suppose there are the 4 carbon atoms or 5 carbon atoms. So if you're having more than 3 carbon atom, then there is a possibility of 2 structure. One is said to be the unbranched structure. In this case, there is no branch. There's a straight chain structure, and there might be the possibility of another isomer that may have the branch structure. So you should be able to draw these both structure efficiently. It is said to be the branch structure. It is said to be the branch structure, and it is said to be the unbranched structure. So that's all about today. Thank you very much. Have a nice day.